And we are live again, Cloud Foundry After Dark, and just joined James Waters. Come on down. You're the next contestant. So we have a couple topics we can talk about, but one of them we're really interested in and kind of hot for the new year we're kicking off is Internet of the Things. What do you think about that?
I just want to say up front, I've been working on internet technology for like a decade or more, and I always thought that things were in the playbook, so I was a little surprised to find them suddenly added this year. I didn't get the memo that we weren't working on that for the decade prior, but I'm glad that they're now formally on the roster.
Well, I mean, we have been tweeting to our plants and random items, so I think part of it is just where we are on the hype cycle roller coaster.
Arnie, what's going on out there? This is Arnie's hour. I just want to hear from Arnie. We're talking to like the top 10 industrial companies in the world about IoT on Cloud Foundry right now, and a lot of them are moving. So what's happening?
Arnie's frozen.
He's got a good poker face.
We'll see if he comes back. First we got to make the internet work, and then we'll get things on it.
Yeah, pretty exciting.
So meanwhile, back at the ranch, what else is going on? This is like the first one after the new year.
Well, I mean, as you know, we had like an awesome end of the year, a lot of great customer stories, a lot of exciting new things to go dig in with now on with folks coming out. So it was pretty exciting new year. But I think we covered a little bit of that in our. I found it really hilarious that people started tweeting our supposed to be secret, not seen hangout.
It got a little microservices run.
Yeah, I would think it was your one quote that people tuned in for, so that's pretty exciting. Where's Arnie? I guess.
I don't know. We were all jazzed up for some Arnie.
I was all excited just to listen to Arnie. Now I'm
Internet of Arnie, and now we got nothing.
Yeah.
I think it's going to be an interesting year for platforms in general, and especially Cloud Foundry. Obviously, there's still a lot of work to do.
Yeah, Arnie's hit me up. He's like, I think he's on his way back in. He's like, Hangout's flaky on me.
And we're back. Now we have two Arnies. Try again.
All right, is this better? Can you guys hear me?
Seems like it. Tip your hat down so we can see what it says.
Yeah, it's weird. You never talking fun. The minute you went on air, it just froze on me.
We'll blame it on James.
We just like to prove that we're live every week. We just don't want people to think this is in any way edited or staged.
I can show the rain and snow falling outside my dark window. It's live. Yeah.
So we were teeing you up, Arnie. I mean, I think you've got an incredibly well-kept book of conversations going on right now where you're able to see across some of like the top 5 or 10 biggest industrial companies in the world what they're doing in terms of funding concepts around IoT, and a lot of them are thinking about, you know, what kind of platform do I need for that, what kind of apps do I want to build, and I think I just wanted to tee you up to have a little bit of an open mic around that.
Yeah, I think at least in our job, we're pretty lucky to be meeting a bunch of these clients, and most of these guys we've spoken to, have seen some version of IoT in the past. It's called a different thing right now. But the evolution is, and if you look at SCADA and M2M around the plumbing of data, basic operational monitoring, but most of them are point-to-point solutions. But it is some sort of that existed. And you look at energy meters, right? A lot of those firms. You speak to security firms. You look at fire firms. These industrial guys, they had some kind of monitoring happening, but it was all done with with a very monolithic single application, which was more maintained, more tailored towards operational efficiency and less for creating new apps uh, to increase the top line. This is more of how do I save money so I can increase the bottom line. So that was their mind thought process. But I think the last 2 years, what these guys are, last year I'd say, if you see what GE is doing, right, and that's fairly public, our relationship with them, and some of the other guys, names of which we cannot provide without. I think some of them are public.
GE and Philips are our two big public certified IoT reference customers.
Yeah, I mean, and the GE's investment in Pivotal was driven by their industrial internet manifesto, right? I mean, Jeff Immelt and Down have been speaking about the impact of IoT, and they used to call it industrial internet. The industry is calling it IoT. I think they made a big claim on that. Our relation
Did we lose him?
within GE. Um, could be G Energy, transportation, even capital. G intelligent platforms, appliances. Each and every one of them have their own nuances around what IoT means, and that's given us a fair amount of access on how do you collect the data, what are the different steps of data collection, what do you do with the data once it's collected, what do you do in some cases when the data is coming in really fast, like in gas turbines, a massive gas turbine plant, hundreds and hundreds of thousands of messages coming in per second. So, the trying to blend all that into a single platform and trying to build richer applications on top of that is the biggest demand at least we're seeing right now. Right?
So it kind of begs the question: does that end up being a single platform? Right? Like there's the generalization of some of these things, but when you look at all those different use cases, what you're trying to solve and what you're trying to connect is it actually collapse into a single platform. I think it's easier to, when you think about how the internet works and the back end, it's easy to imagine that there's these back end systems that look something like a platform like Cloud Foundry, but the actual protocols and the way that you're going to interact with each of these things in every case, does that collapse into a solution?
Yeah, and that's the big shift that's happening between M2M and IoT. And M2M is the first case wherein it's one app at a time. There's rarely ever a platform. It's each point applications that's going one at a time. So for example, an extremely big industrial, right? They're roughly $10 billion in revenue. They're a well-known player. They have silos of groups working on different devices. Now, Home Depot, for example, is a huge client of theirs. Now they have multiple of those devices sitting doing their own thing. Now each of those divisions don't even speak to each other. And they have their own lightweight M2M platforms. The question then becomes are there ways in which you can grab data? Are there ways you can model things, events, and actions that look at these devices cross-section and not just look at just one of them, and then say, if this happens here and that happens there, within this time window, I want to do something interesting. And some of the processing could be local, some of them could be remote, and then exposing those devices as an ecosystem to the world outside. Could be partners, could be pushing it back to the clients themselves. Because a lot of clients, for example, Home Depot in this case, might say, I want to build applications based on the data that I'm generating myself, right, without having to go through crazy ways. It's already being instrumented. The sensors are already there. Can I build applications on top? So then all this boils down to is, are there APIs? I mean, platform is a loose manifestation of APIs. So are there APIs that I can connect to so I can get more value out of the data that's being driven out of my devices? And that's what is pushing the need for a platform. No question about it. Almost everybody, right? I wish I had the slide. Can I show slides on this thing? I probably can't.
You can. If you go to the far left side and hover, then the green box.
Yeah.
Let you screen share.
You can, and take your time, because only crazy people that want to stay up late on a Sunday night watch this. So feel free to go in depth. That's why we do this after dark. So you'd have to be hardcore in.
I think there's another thing that's worth at least thinking about. I mean, what you just described is sort of this event-driven system where you're trying to do whatever, correlation with some sensor network, and maybe have, a combination of sensors and actuators that are doing things. But I think there's a bunch of Internet of Things use cases that aren't going to be. I mean, that sort of drives towards these real-time, event-driven architectures. There's a bunch of data that the time signals are not going to be
Yeah.
on that order of, the time sensitive. Like, it's more about analyzing the trends, analyzing, just having the data in a format where you can do the queries and the processing after the fact.
Yep, and that's exactly GE aviation, right? I mean, that's one of the most storied use cases we have at Pivotal. And I mean, I don't know how many of you guys who are going to listen to this later or who are live right now know about GE aviation, but they're one of the biggest makers of jet engines in the world, number one. And what makes this interesting is the amount of data that's collected when a jet engine lands is roughly, depending on the engine, depending on the plane, depending on the airline, 2 to 4 terabytes, right? Which is not that much. But what makes this doubly interesting is there's a GE engine, or rather a plane with the GE engine.
Arnie, talk to me. Is it a technical difficulty with his internet provider?
He's in a big storm there on the East Coast right now. Hopefully it's not affecting the fiber or the optics. His screen share looks like it's still coming through.
Yeah, but that could just be frozen.
Yeah, probably is.
So he was just going to do the math, I think, for how often the jets land, and so you're getting 2 terabytes every landing.
Yeah, you get 2 terabytes, and oh, that's somebody else. And a lot of the value add that they want to do is just time series analysis of everything that's really happening across everything that they've installed. So I think the thing we were debating on Skype earlier, though, is that where should that analysis happen, right? Should that always be like, hey, bring it back to a big, large-scale data center? How much should be managed at some point closer to the data creation?
To me, it all comes back to what you're trying to do, right? And if you have a need for super low latency, event-driven response to some changes, and you're going to insist that everything goes back in this highly consistent manner to some centralized processing, then you're going to have a hard time pulling that off at scale with the type of stuff people are talking about. So you're going to need much more, edge processing to do that kind of stuff.
Yeah, but at the same time, if you want to correlate how that engine looks versus every other engine that just came in that day, there's some transportation cost to get all that data to be in one place and talk to each other.
Sure, but and I agree, and you're gonna bring all that. I mean, that's a use case where it's almost purely analytical, and you're gonna bring them all together so you can make those comparisons.
Yeah.
But some of the other use cases we were talking about have more to do with actuating, responsive, event-driven things in real time. And if you're going to, the transport and the latency or whatever to do that is going to be non-trivial, and in many cases maybe a non-starter.
Yeah, I'm also an advocate and interested in just even the basics for a lot of people. So today there's not like a consistent identity and a consistent API backend for everything that Philips makes. So when they came to Cloud Foundry a year ago and said, we're going to go build a consistent online identity for everybody who consumes Philips medical products, be they in a hospital or in personal, we want one platform to do all of that. There's also some low-hanging fruit, right, where every product group would have its own, before the way it worked was every product group would be like, okay, here's the heart monitoring team. All right, now we've built our heart monitor online site and our heart monitor identity, etc. And there wasn't like a sense of common services across that because every product team built their own little piece of software as part of their own product mission. So I think the platformization of some of these companies is interesting too, where they weren't always collaborating across products in terms of connected experiences and thinking in terms of customer identity, etc.
He's back.
Arnie,
Sorry, this is not good. All right, hopefully this one's better.
I don't know how you're so good at your job without internet. I had no idea you were fighting through such hardship.
Dude, it's Google. Everything else works fine. I don't know what Hangouts does sometimes.
Is that Amit who's on, by the way? Diego Engineer Amit? Or is that a different Amit?
He's muted.
Yeah. All right.
So you're just about to do some math with the number of jet engines that are landing around the
Yeah,
world.
I don't know when I lost you guys, but
You were explaining that there's 2 terabytes per landing.
yeah, so terabytes per landing, and roughly every 2 seconds, an engine takes off or lands, or a plane with a jet engine takes off or lands, which is a lot of data, right? So that begs the question: how can you get this data real time, right? Is there a need for it? Now, in this case, there's no reason for it at all. So this is one of those classic IoT use cases where the data volumes are extremely high, but none of that is real time, right? It's all coming, it's all coming batched in via boring FTPs or some kind of advanced file transfer protocols wherein you can move data fairly fast. But
So just out of curiosity, what kind of questions are they asking of that data?
yeah, good question. So it depends, right? So there's 2 views to the data spectrum. So one view is me as a client. I'm interested in are my engines performing efficiently? If not, what do I need to do so I can get more efficiency out of those engines? Number one. The simplest would be to save gas. That's the simplest. Even more advanced would be, I don't want a fail part right in the middle of a tricky route wherein it's almost impossible for me to shake myself loose because I don't have spare planes, whatever it is. So predictably, can I find out and ensure that I won't be painting myself into a corner? That's number one. And the way this is exposed is all this data lands in a pretty massive, data lake, right? And they've exposed these algorithms that they create via custom portals to a bunch of airlines. So if I'm, a big airline who is a client at GE Aviation, I'm opened up a portal wherein I can go in and look for information that would unlock some of the data through those algorithms to me, so I can do predictive maintenance and all the other fun stuff that would have just not been possible for me in the past. Right? That's number one. On the flip side, GE is happy because they can tweak their maintenance schedules, and so that they can increase their net revenue they bring in. Right? So both parties gain, with data being the arbitrage between between the situation. Before they didn't have any of that stuff, so they're addicted to this. Right? So the latest locomotive that's coming out of GE, and you can Google for this, is super advanced. Number of sensors on that are 2,000 times the number of sensors that sit on an existing locomotive. The amount of data that's going to come out of locomotive is just crazy high. Right? It's going to be in line with where you have jet engines. So that's another huge thing that we're going to see.
So they're basically going to go through and instrument their portfolio with more and more of these sensors.
Across the board, right? I mean, anytime you have a soda, you don't realize it, but there's water. There's a lot of water being filtrated. There's so many water filtration plants around the U.S. That all come through GE water, right? Again, the pH level, right? There's a whole bunch of metrics that are measured constantly, and stream back to systems where they watch what's happening. Right? That's another massive one. GE Energy around gas turbines. So they have wind and gas turbine massive plants, which again stream off data. Now that's the other use case of IoT, wherein it's not just the volume, it's even the velocity, because the amount of data that's coming in from gas turbines is like hundreds of thousands per second, like I said before, I think. And they want to build applications on top of that. Some of them are simple predictive maintenance. Some of them are more advanced, wherein they want to build a platform and open up that data to their partners and their ecosystem to get more value out of that. And that's huge if they can do that. and a lot of clients are thinking of doing that, and that's why the need for a platform to get that data, to hold on to some of the data, but find ways in which they can parcel the data out to their own devs, to their clients' devs, to partner devs, so the guys can get more value out of the data. That ecosystem is just strong. Look at Nest. Started as a closed system, but they're opening it up. They're opening that data, right? A lot of interesting stuff.
So, what role do you think the platforms that we're trying to build fit into these solutions, or what is your? I mean, you're in these conversations right now, trying to help people. And it seems like if these aren't solved problems, right? Like there's a huge opportunity to find better solutions to all these things that we're talking about.
Yeah, I mean, that's why I wanted to pull this chart up for my friends at Harvard Research. They're a boutique, research firm, but focused on M2M and IoT. Chart, shows you along the x-axis the kind of systems being instrumented. Is it a single set of systems? Is it multiple? Is it many more? The simple, compound, complex, right? The sophistication of the instrumentation, and the y-axis is the kind of benefits that clients are seeing. The bottom could be, like the old M2M stuff, right? Very basic, switch on, switch off. Second could be improving a little bit more operational efficiency. And the third is providing some massive improvements to increase the top line to this. Right? A lot of the industrial firms, and we're speaking to at least a half of these, if not more than that. Some of these are already our clients. Some of them are fairly public, right? GE and Philips have spoken openly, but some of the other ones, actually, you know what? Except for one, we're speaking to each and every one of these guys. And the need for a platform is: are there ways in which we can take the firms in this lower end here, and this is just a small sampling, right? And the market is probably 100 times the size of this. Are there ways in which we can move them along the x and the y axis, and deliver true value to them by connecting lots of different kinds of systems that they build, manufacture, and sell through a range of channels, while at the same time increasing the top dollar? And my argument is that the only way you can do it is by using a platform, right? And this is broadly the argument that's being made, not just by me, but by a lot of the CTOs. I've spoken to the CTOs, a lot of these firms. They're essentially saying GE is doing that with their Predix platform. They're basing that on a whole bunch of pivotal technology. Philips is building the digital health platform, again, based on top of pivotal technology. We'll see more and more of these names pop up, but the need for a platform to move along the x and the y axis extremely strong.
And the alternative is you end up doing a lot of undifferentiated heavy lifting that's replacing or repeating what someone else did.
Yeah. So, and let me see if I can pull that one up, right? And I make this case very hard with a lot of the CTOs I speak to. First of all, I tell them, platforms are hard, right? I mean, we know that, the core value prop for everything we see around Cloud Foundry. It's not easy, right? There need to be support for multiple cloud, multiple languages, scale up, scale out, self-healing, and APIs, and all that fun stuff with the big and fast data we spoke about. If platforms are hard, the argument is IoT platforms are harder, right? So you can't start from scratch. You can't just take a bunch of loosely built 1980s M2M systems and then say, I'm going to build a rich IoT platform out of that and unlock an ecosystem. You can't. You need a solid base, and more and more examples. We are seeing, a PaaS in general and Cloud Foundry specifically being the base for a lot of these IoT platforms.
Yeah, I think, Arnie, especially if you look at the microservices part of this.
Yep.
As opposed to everybody writing a big new monolithic end-to-end app that does everything itself. Being able, as I was mentioning with Philips, being able to reuse, things across the platform and having product groups share a connected platform, I think, is going to be an important part of this.
Yep. And this question comes up. There's a few IoT players out in the market, right? It could be ThingWorks or Machine Shop or some of these names. I just put 4 in there, but there's at least 8 more. A lot of the industrials say, do I need a platform? Can I just use one of these point solutions and get up and running? And that's precisely this point. An IoT platform is a platform to begin with, which is not easy, and it'll take a long time before any of the guys can build some of the robustness that's there, some of the richness, the abstraction that are burnt in Cloud Foundry. So much so that at least one, if not 2 of the guys you see in this list are signing up to be partners, to be certified on Cloud Foundry. So they do a few things really well, like device modeling, OTA updates, and virtual device profiles. So they have a deep domain knowledge, so they're great at that. And they struggle to build a platform. So they're essentially saying, hey, we'll build our products on top of your platform while we do what we're really good at, writing on top of what you guys already have. So my guess is, if I had to look at how 2015 is going to head out, is a lot of IoT platforms that are being built in the market right now will be built on a PaaS-based platform, number one. They'll be heavily microservices based, because of the nature of how these platforms need to be built. And we'll see most of these guys become services on those platforms, so you can get a jump start in doing some of the things that each of these platforms are well known for. That's my guess, based on speaking to both sides of the equation.
Hey, so we gained somebody, Joe. We've not met you before. At least I haven't.
I'm just an internet human being, just joining the listening.
Okay. Welcome. Just wanted to acknowledge you were in the room. Nice to meet you. Internet human beings, internet of humans, Arnie.
Yes.
The internet might work. This might work.
Yeah, I think that protocol you're using
San Francisco.
Huh?
I think Joe's in San Francisco. What do you work on, Joe? So.
Right now I'm writing a. Hopefully, no one on LinkedIn is on this call. I'm writing a bot to apply to jobs. I'm unemployed, so that's what I'm doing right now. I'm a Rails engineer, so.
All right. Well, we're gonna find Joe a job by the end of the night. A good one. So, so Arnie, that's exciting getting those guys to run on the platform, right? Because then it's sort of like you've got some of the out-of-the-box microservices when you start. I mean, I think that's the affirmative vision of working together with those companies is you don't have to write every microservice yourself over time.
Yep.
And I think 2 years from now, if we have a series of microservice ISVs, that would be pretty interesting for IoT.
I mean, I think it's about looking for those use cases that map into either existing solutions or coming up with new solutions. One of the things you said earlier about you can't just take these old protocols M2M and kind of smash them together and expect to have a platform that you can operate at the scale, with the reliability that you want. So maybe it's worth talking a little bit about what's the opportunity to innovate in this space. Where are there clear solutions that people should kind of be getting behind and building their solutions on top of, and what are the gaps right now?
Yeah, I mean that's also a good one, right? I mean, across the value, across the end-to-end pipe, from the point where the device is measuring stuff and is trying to transmit the data to the backend. There's a lot of innovation happening there. There's a whole bunch of VCs just focused on that. I have a bunch of friends who work, and all they do is they invest in extremely smart sensor technology. They're just doing that day in and day out. That's one. The second is the communication protocols, right? Could be inside the local site. So, for example, again, if I'm an extremely large factory, right, and I have many of those factories along the value chain of whatever products I'm making, there's a whole bunch of information that's being created and being sent out. I want to do a lot of local processing. So there's the intra-site protocols could be mesh-based, whatever it might be, because keep in mind, not all devices need to speak to each other. They may have to speak to gateways. So there's some innovations happening around the protocols within the site. That's number one. And the second is the second leg, which is the data happening from the local gateway to the backend systems. what kind of protocols do you want to use? Right? Should they be the request response? Should they be pub sub? Should it be one way? Should it be two way? Right? For example, do you want to push data back? There's a few standards that exist right now: MQTT 3.1, COAP. MQTT came out of IBM. COAP came out of Cisco. But most of those protocols still, MQTT itself is an old protocol, right? IoT has made a few more strides, and there's room for improvement even in MQTT. Andy and team, they built what they could at that time. I don't know how many guys know about MQTT, but essentially it was IBM MQ series being extended to support smaller devices, right? And hence the MQ. So there's scope for improvement within that protocol, without question, and a lot of practitioners realize that, and they've kind of worked around it for now. The biggest problem is too many players and not enough consensus to create standards. As a result, nothing's happened. Right? We've had one or two standards created death by committee ways, but for the most part, it's not emerged to be a compelling, technologically, innovative or a good standard. Right? That's from a protocol standpoint. Security is another massive thing in IoT. If you thought M2M was bad because you can have one hacker take out a part of the grid, imagine IoT, right? You're just opening it up to more people. You want to get the value out of all the data that's coming out, but then you have security problems that might happen. So how do you manage the authentication and the security? And there's a couple of firms that just focus on the security for IoT. So that's a ton of innovation happening there. Now, flipping it completely on the back end, which is, okay, all my data is streaming in from my different sites. The time series databases are still so far behind, right? The existing databases have mostly been either relational, NoSQL kind of sort of has taken off, but there is a need for an IoT style data store as data streams in. This comes in every time. So either existing NoSQL tools have to be retooled to support time series and corresponding and not just time series. And time tick databases have existed in Wall Street for ages. But from an industrial scope, the patterns, the query operators that might need to exist, right? There's a lot of scope for improvement around both stream processing of time series data as well as large-scale analytical processing of time series data. And the last part I see is a visualization of time series information, both real-time and batch-based. Because most of the existing tools, they don't do a great job. I mean, if you look at Graphite, there's a bunch of tools, but it's mostly tick charts, right? I mean, are there smarter ways in which you can visualize this time series information and do time series analytics? So across the board, I see scope for innovation. The question is, how is the industry going to rally to do all that stuff? Because each of them are pretty unique in their own smaller domain.
Yeah, and I think just from my perspective at a macro level, what's exciting is we went through the year and we never said the word Internet of Things once in our marketing, right? Like we weren't really trying to just like say a word to say a word. But then, catching up with you in terms of how many people were coming to us asking for advice to do major build-outs, it became obvious that some of the biggest companies in the world were going to start writing software at a pace that they'd never done before, right? Like these are not just the same old, basic embedded systems. Like there's going to be I think, a renaissance of new applications that might get developed out of this phase.
Well, it's interesting to watch because as soon as they flip the switch and they see that these are opportunities to create top-line revenue,
right?
Then they're highly motivated to take on these projects. And in many cases, software is such a new thing for some of these enterprises. I mean, not that they don't have developers and not that they haven't had projects, but just the scale and the scope of what they're taking on. It's not the same as like the little business supporting applications that they're kind of used to doing with just rubbing some outsourced development on it.
Yeah, I mean IoT has been unique, at least to put a pivotal angle to it. We've had the best kind of marketing there is, which is classic customer-based word of mouth, right? We don't have a single white paper. We haven't explicitly spoken about it, but We've had clients come to us and say, hey, we've heard GE speak about this stuff. We've heard some cool things you've done for this industrial. We'd like to do some of the same. We've become the de facto. We do audits now of end-to-end architectures for IoT for some of the biggest firms you can think of, and we don't even offer that as a service, right? People just come to us because
they just want our experience.
yeah, that's it, right? And that's it. They just two of the biggest telcos in the U.S. That should be easy. Are working closely with us on IoT projects. That's huge, right? Obviously, because telcos are massive of IoT. They offer the backhaul and all this data that needs to be moved. The I in the IoT, where you want data moved around, the telcos have a big role to play. And guess what? Two of the biggest telcos in the US are working closely with Pivotal again. So, for good or for bad, we've had the right kind of marketing for IoT at Pivotal, which has been customer driven and word of mouth, which has been great. Just great.
So the opportunity to solve some of these problems and the projects that we have a front row seat to participate in, is there any leading candidates to solve some of those problems? You said there's not become a standard. There's no de facto standard. There's no standard that people are really collapsing or supporting. So is there a way to sort of hasten that occurrence, or is it just sort of sit back and watch and do the best you can?
Yeah, I mean, from that perspective, I think Pivotal can play a bigger role, right? If you look at the set of consortiums in the industry, in 2014 itself, we had 4 consortiums being created. You had the IIC, right, the Industrial Internet Consortium. Then you had the OIC, which is the Open Interconnect Consortium. Then you had All-Seen, and then you had IPSO, right? You have 4 consortiums around IoT. Now, some of them are focused on different T's. Like All-Seen, for example, is 100% consumer, focused on TV, set-top boxes. So those are the special things they're focusing on, which is why LG and Sharp and Panasonic, etc., really focused on that. Samsung has not joined that. They're trying to do, obviously IoT is huge for them. They made a few key acquisitions in the last couple of months. So everybody's watching what they're going to do, right? The IIC and the OIC are mostly industrial, right? Both of them have Intel and GE and Cisco all over them. There's no question there's need for standards, but the market around the T is so fragmented that we need to be smart around deciding what kind of protocols, what kind of standards do you want to use based on what kind of T's. And some of them have common patterns, but if you look at mobile devices are treated as a T, right? One of the biggest media firms in the US is a massive Pivotal client, and every time you use their app, and easily there's 40 million people using that app right now as we speak, right? Every time you use that app, a lot of analytics are collected in the back end, stored in Cloud Foundry on a big data lake, and a fair amount of analytics is being done right now on all the data that's being collected by those mobile phones. So in this case, it's an internet of mobile phones. So what exactly is a T? And as a result, what standards need to be created? We gotta think about that one.
That's my biggest curiosity, is this blanket investment term that we're using. How close? I think Andrew started off here. How connected or similar are the use cases going to be? And I imagine there'll be a couple families of use cases, just like you have families of application designs today.
Absolutely, and that's why you'll have more than one protocol, right? I mean, XMPP was seen as an IoT protocol, and people would smirk and say, "Why would you use XMPP? That's like a completely different set of use cases." But guess what? If your device is one of these things, which is always connected, has got reasonable amount of battery and power, it's okay. Who cares? But if I'm a small device sitting in a low power, lossy network, the kind of protocol I'd use would be completely different, right? So there's no, we got to look at these classes of use cases, and as a result, do some interesting things. But no matter what, there's going to be one common thing, which is applications. Those applications are going to be built on top of a platform. And biased as I am, the argument is you need a PaaS platform to build those use cases. Simple stuff, right? How do you organize the application? How do you organize the data flow? What protocols would run on it? As a result, what tools would run on it? All that would change based on the family of use cases, but there is a need for a unifying simple platform.
I mean, the reality is, on some level, all these protocols for gathering the data and interacting with the device is one thing, but for the most part, the apps that get written, they're mostly going to be interfacing with humans, and they'll probably use sort of the standard interfaces with browsers and mobile devices that we're used to.
Yep. Yep. Absolutely. That's at the end of the day, we want to make those things look like usable things for humans. Right? I mean, all these things are useless if they're not helping the life of humans. Um,
Well,
That's not what the machines think, Arnie.
Singularity will come, my friend. Singularity will come. Just it's going to take a few more years. Let's build some real applications before the machines take over.
Enjoy it while it lasts.
Yeah, I'm a huge Kurzweil fan, so peace on that, no question.
Hey, just 14 more years, right?
14 more years, according to him. It's happening.
14 more years until printers work? What? Well, that was great, Arnie. I mean, I've just been having so many rich conversations with you about all this stuff, and I feel like it's been one of our better kept secrets. So I thought, at least for the 10 or so people that like to watch a late night hangout around this kind of stuff, we could share with that inner circle, if not the average person.
Yeah, no, this is an exciting space, and we're going to be back on that journey next week, meeting more of these clients and finding more use cases. And some of these use cases are crazy. Smart cities, right? I mean, who knew that the government can get innovative, right? A lot of these cities are finding ways. They're struggling. They need money, right? And they're just getting bored of just raising taxes to make money. Not just bored, they're getting slammed. So they're like, what can we do? Who are our assets, and what can we do to get more money out of the assets we have? Right? It could be a dumb old street lamp. Could be a trash. And I don't know if you've seen Big Belly, which is like this fancy trash can, which has a solar panel on top. And you'd be like, well, why the hell does a trash can need a solar panel?
Compact.
Because inside its belly, which is why the big belly, they have a compactor that constantly compacts stuff. And the minute it gets full or it's getting close to the point, it wakes up and it alerts someone to say, I'm getting close to full. Someone clean me up, right? And all that connectivity is actually provided by Verizon in this case. And for them it's cost nothing if you think about it, because they don't need an LTE, a 4G, a 3G. It has to be a very low bandwidth connection, and that's a part of the spectrum which is going unused. Verizon's happy because they get to use spectrum which is not used. The trash goes away faster, and the trash trucks are more efficient. They're not doing unnecessary circles. Citizens are happy. So when they come back for a check, they say, hey, we need to invest in improvements. They're seeing more citizens come out and say, yeah, this thing is actually working for them. So the smart cities are slowly taking off, and I think we need to find ways in which we can build some smart city applications. That would be insanely cool.
My mind was blown talking to our friend Ben this week around, and I kind of knew it was happening, but I hadn't seen it up close. This new Intel Edison, which we've had the Raspberry Pi out for a while, which is ultra low cost.
Yep.
But this is a straight up Intel processor, 1 gig of RAM, 4 gigs of SD storage, low power, Bluetooth, Wi-Fi enabled. This is a full computer a couple years ago, laptop computer a couple years ago. It's $50. And it's the size of a SD card.
Yeah, I've heard about it. I've not played with it, and when I saw the announcement, I saw it, but I haven't. I mean, I have the Raspberry Pi and the Arduinos, but the Edison was new.
Yeah, I think what was cool to me was that you're now taking like the world's most software-abundant architecture out there in the world, which is Intel, and all of the stuff that we've built, for Intel over the years. And you can run it in an ultra-low power, ultra-low cost way. And Andrew, I think when we do the Lattice stuff this year, I think we're gonna be able to get Lattice running on a Edison, and you could imagine a couple of containers with a consensus algorithm running to make sure the health was continuously available. You could imagine Edison running a very micro-edge kind of platform for us as well, where you can fan out. I know Philips has been pushing on us hard of how small of a form factor could we fit into.
Yep. And I mean, two of the biggest chips right now, and Intel is catching up on that space, but two of the biggest ones is the TI MSP430. I mean, that's a very, very popular chipset for these. And then the Freescale, I forget which one, the exact model. But those are the two most dominant chipsets for these things. And Intel is playing catch up in this space, as they should be, because they were focused on on laptops and the mobile devices. But I think the other guys have had TI and Freescale for sure have had a jump start on that.
I feel like, and you know, you guys can throw your speculation in the ring, but this is just the very, very beginning of transformation in the way information is available and the way it's processed. You know, there's the cloud and whatever. We're kind of in the middle of that, maybe. You know, just maybe the first third of that. But this is going to open up a whole another layer of innovation.
Yeah, I mean, yeah. Despite all the hype, I think
what you got, James? That's the little Edison.
That's it. It's the same size as an SD card, and it's got basically it's a full x86 system running on that card.
Holy cow! Yeah.
Well, until I finally saw it and I realized it was a gig of RAM and everything you need to run what would have been a server 5 years ago on that card. It kind of blew my mind about where the future could go 5 years from now, even in the x86 world, not just ARM and all the new chips.
Yep. Yeah, the question is how much battery does it consume? Have they figured out? And they're using the 22 nanometer for it, but the question is how much. Because most of these devices, they don't want to be power hungry. Right? You don't want to touch them for years. In fact, some cases even more than that. Power is a resource.
I think there's kind of like
this goes back to the statement that there's a bunch of different use cases. I don't think you always have to assume.
Oh yeah, I get it. No, of course, yeah, of course.
I'm thinking of like the Philips use case where they're like, hey, we want to run some software in an MRI machine, which is, you don't want to have to put a whole big server into it, but you could imagine doing a little bit of damage in something that's plugged in and on the edge, or.
Yeah, I mean, an MRI machine is not going to be power constrained at all.
No, I think there's a middle tier of connected things where it was just too hard to get a full x86 architecture running on before to fan out, but you can do some interesting things with it now. I don't know. I was very fascinated by the form factor, having Hey.
Have you guys heard any like improvements in very low power wireless charging, power transmission, or is that still very far away?
I know there's a company here in Pittsburgh, these Carnegie Mellon kids, that did some stuff. What's their name?
Yeah, I mean the whole power space, a lot of room for disruption.
And I think whoever gets that right will have opportunity.
Yeah. A lot of hype, but I think there's some substance to the hype. Like all things capitalism, all things venture capitalists, there's a lot of money flooding here as usual, but there's some merit to this if done right, and if you can get a couple of key players to play along and see enough value, right? I mean, Cisco's all in on this because they see, anytime you see bytes flowing, juices flow through John Chambers' head, and he wants to go after that space. GE as a consumer wants to benefit from it. The big telcos want to benefit. So there's enough money to go around if this thing goes right. Just I want to have some of the key players work this out, so the next 2 to 5 years we'll see some spurt of innovation in this space. I'm excited about this.
Cool. Well, hey, I think we should wrap this one early, Angie. We've been going over by a lot, and I know Arnie's got a lot of damage to do outside of hanging out with us.
He's got work to do.
It's midnight. Just get started here, right, Andrew?
That's right. The night is young. I'm trying to look up this this inductive power stuff that I was looking at before.
To charge stuff. I got one of those at home to charge. What the hell? The toothbrush.
So these guys here, it's a Carnegie Mellon crew, or at least some of them are. It's called PowerCast, and it's a wireless power, wireless charging technology. It looks pretty cool. I was looking at their specs the other day, and I know some of them because I live here.
Yeah, there's a guy called Steve Perlman. I think his company's called T-Cell. He's trying to pretty crazy technology they're working on, but basically he said we could. He's promising like 5G LTE speeds, like in a year. He's like, yeah, our technology could also possibly be used to transmit power. If you guys check it out.
What's it called? What's the company?
Artemis Networks, ARTE. Let me find a link.
Artemis Networks, okay.
Yeah, they've been around for a little bit of time. They've been at this for a little bit of time.
Yeah, I really think that the power question, we didn't touch on that at all, but I mean, maybe that's the opposite end of the reality we live in. But you have to look at these things. I think there's a huge opportunity to optimize the batteries, optimize the power transfer. I believe there's like inductive chargers and like these field chargers are going to be game changers when they get good.
Mm. Yep. And speaking of charging, the fancy, expensive all-electric vehicle we were speaking about. I mean, they're building a massive IOV platform. Obviously, the V here is vehicles, and they're not alone, right? Some of the best names in business are trying to find ways in which they can connect cars in more meaningful fashion. Last thing you want is cars speaking to each other. I don't want a guy driving next to me chatting to me. It's annoying enough they honk at you, but I think these iPad on wheels, which is what we call some of these vehicles because they're so fancy, the kind of connectivity they have, and they're doing their own innovations around power management. You saw Tesla, improve their miles per charge by a good chunk last week just with the software upgrade.
Like 30% or something, right?
It's a software upgrade. 2 clicks on their side, and the vehicle all of a sudden like, ooh, you're getting more miles on the charge. So some extremely interesting.
I mean, that's like the perfect use case of everything we talked about. Being able to analyze the efficiency and with the software update, change the dynamics of your cars. Like that's insane.
Yeah, so I was in the factory of one of the best BMW manufacturers, automobile manufacturers, and their executive is speaking to them, scratching their head, saying, "How can a firm sitting in California create a luxury vehicle, running all electric, and go after their cash cow?" They're just scratching their head. If software is eating the world, nobody thought. A German car manufacturer never thought that a car built on software is going to come and change the way they operate.
That's my favorite talk track. Is like they're like, why is the fastest growing car company in the world from Palo Alto, California?
Yeah, exactly. And guess what? It's software. And guess what? It's a platform behind that. And the applications is built on top of that. Some seen through the views of the drivers, and some seen through the views of the operator. In this case, who was running the Tesla network. But it's huge.
Yeah, I mean, we have driverless cars right now that are all built on running on dumb roads. But imagine if you started having more sensors and more like consumable built-in information points, not just like derived from a camera, 3D camera that's mapping where it's going and GPS.
Mm-hmm.
And I mean, to the point you made a minute ago, I kind of want the cars to talk to each other and not run into each other.
Oh yeah. As long as the cars speak to each other, not the drivers speaking to each other.
That's perfect.
That's fine. Machine to machine is absolutely fine as long as it's mediated. And I think a glimpse of that sensors on roads and the vehicles driving on it. So we did a fair amount of work with the G rail as we were grabbing data out of the locomotives. Well, as I was working through the project with the CTO there, we figured out that a fair amount of the train tracks in the US are heavily instrumented. So anytime a train goes over the sensor, you can actually, on the fly, like literally, freight, mostly freight, not passenger, given how the U.S. operates from a rail traffic perspective. But when a train goes by, they can measure the temperature of the wheel and the temperature of the ball bearing as it goes by. And you're like, why the hell are they measuring that? Now, the biggest cost for a railroad company is the maintenance of the wheels, right? It's the steel around the wheels, the steel and the metal around the wheels. If the temperature is higher than the ambient temperature or the average temperature of the other wheels, it means it's not rotating fast enough. There's friction. Something is causing problems. And they can alert that really fast based on some preset metrics. And that is streamed, by the way, real time to a backend system. So they watch for a bunch of things. Temperature is one thing they watch for the most. But for every, I think, 25 of those temperature sensors, they have an acoustic sensor that listens to the clickety-clackety sound. So the sound has a standard fingerprint, but for whatever reason, if something is wrong with the wheel, they can watch for that clickety-clackety and then say, oops, this sounds like a wrong wheel, and they can pull it over for inspection. So, James, the point you made about the roads having sensors and then the vehicles reading off of that is already happening on rails right now. We just got to expand that to roads.
That's right, because railroad's a controlled environment, right? So it's an engineered road is all it is.
That's all it is, and we'll see that hopefully come back. And this comes back to the smart city statement I made, wherein if let's say the New Jersey Turnpike, I'm living in Jersey, came up with an idea to light up sensors that vehicles could read, and then you could provide some of that value back to clients. Right? I'd buy something like that. Absolutely, I'd buy something.
I hope 10 years from now, I mean, this is less about platform and Cloud Foundry. This is more about my own quality of life. I'm somebody who's pretty much abandoned driving, and I just take Uber everywhere. And it annoys me now to have to drive. That's time I can't be reading something or being productive. And I think we're going to look back 10 or 20 years from now and be like, wow, I can't believe we used to be barbaric and force people to sit in steel boxes and navigate their way through high traffic, rapid speed, and people would die by missteering. Like, I think that's going to look as barbaric as pre-penicillin medicine.
Yeah. James is making predictions.
No, I'm just saying, like, you know how, when you look back on your age, there's always some things that you took for granted that seem barbaric later on because there's such a waste of human imagination and productivity or life. And
I'm not sure I'd go all the way to barbaric. It'll seem anachronistic for sure, but.
No, I mean it's similar to what people had to hunt in the past to get food.
That's what I'm saying. Like this is
the past time.
Like you had to steer your car. What?
Your television didn't have color?
No, it's like when the kids swipe the magazine now, right? They're like, what do you mean I can't, immediately change the application and the view and the app that I want on this piece of paper?
Mm-hmm. Yeah, it's funny. I mean, we can talk all night. My son's 6 years old. When I told him when Daddy was young, your age, we didn't have Google, right? You ask Google and Siri all these funny questions. He looks at me straight in the face and like, you don't have the internet? Then how did you go? What are you talking about?
Exactly. And I hope someday, maybe I don't have kids, but if I ever do, their kids will be like, what do you mean your granddad drove? What is that?
So James wanted you to get some beauty rest, Arnie, and we made it a full hour. So unless anyone has any parting wisdom they want to give to the internet, should we call it a night?
All I'll say is just watch Arnie and Cloud Foundry and IoT in 2015. It's been a stealth hit. It's been pretty cool to see.
A lot of fun stuff.
It's just the bleeding edge.
It is.
All right. It's Monday here. It's Monday here in the East Coast, so which means
It's Monday Eve, like I like to say.
That means can get to work, right, Arnie? It's like now it's Monday. Let's do this.
Monday. Let's get back. Let's get back. Quarter just started.
All right, we'll do it again.